section, we're going to start getting into some of the special angles, the ones that we see a lot of throughout the year. And we are applying this right now for acute angles, so only things between 0 and 90 degrees. We are going to be looking more at triangles now, so SOHCAHTOA is a really great option when you have a triangle. So remember, what was the definition for sine? It means sine equals opposite over hypotenuse. The ka tells us cosine is adjacent over hypotenuse. And TOA means that tangent is opposite over adjacent. Now, this only works if, first of all, we have a right triangle. Because if you don't have a right triangle, is there a hypotenuse? No. So it has to be a right triangle. And our angle has to be one of the acute angles, so either A or B. I can't do C because then my opposite side and my hypotenuse become the same. And so there is no more opposite side. So it only works from either A or B. Notation from geometry, capital letters represented angles. Sides were the lowercase letters across from them. So if this is angle C, side C is over here. Angle A, so side A would be lowercase a over here. Angle B, so side B is lowercase b over here. So I could ask you to define your 6 trig functions from either A or B, but the angle is important. If I say sine of A, that means from angle A, opposite over hypotenuse. What's my opposite side? A over my hypotenuse is C. Hypotenuse is your longest side, opposite is across from. What would happen if I had said sine of angle B? B over C, so the angle matters. Cosecant is the reciprocal, so that would be C over A. Cosine of angle A, so that's adjacent, that means touching it but not the hypotenuse, so that would be B over hypotenuse over C. So secant is reciprocal, C over B. Tangent, TOA, opposite over adjacent, so A over B, which tells us that cotangent is B over A. All right. Any questions there? So let's use that. Triangle ABC is a right triangle with angle C equal to 90 degrees. I draw myself a triangle. C is the right angle. Doesn't matter which one you call A and B. So side A is 6. That has to go across from angle A. So my 6 has to be down here. Side C is 10. That's across from angle C, so my hypotenuse. If I'm going to do my trig functions, we have to know all 3 sides, so how would I get my third side? have two sides in a right triangle? Just like we have X and R, how do we get Y? Can you use Pythagorean theorem? A squared plus B squared equals C squared. A was 6. C is 10. In these triangles, right now we're only dealing with positive sides. We'll get to negatives later in this chapter. So for now, B is just going to be the positive square root. So that is 8. If it doesn't work out exactly, if it were like the square root of 8, I want it in reduced radical form. So 2 radical 2. Do not change it to decimals. So now if I ask for my 6 trig functions of angle A. So we have the sine. I have to write my A so I know which angle I'm viewing from. So from here, remember this is the hypotenuse because it's the longest side. 6 is going to be my opposite. It's across from it, which means this 8 is my adjacent. So sine opposite over hypotenuse. 6 over 10 reduces to 3/5. Reciprocal of sine is cosecant. So cosecant would be 5 over 3. Cosine. Adjacent over hypotenuse. So 8 over 10 is 4/5. So the reciprocal would be 5 over 4. And then tangent, TOA, opposite over adjacent. So 6 over 8 reduces to 3/4. So reciprocal would be 4/3. I want you guys to do the exact same thing. It's the same triangle, but this time I want the 6 trig functions of B. So, because I switched my viewpoint, if I'm looking from angle B, this becomes my adjacent side, and this becomes my opposite side. So sine of B, opposite over hypotenuse, 8 over 10 or 4/5. So that means cosecant of B is 5/4. Cosine of B, so ca, adjacent over hypotenuse, 6 over 10 is 3/5, which means secant is 5/5. Tangent, opposite over adjacent, 8 over 6 is 4/3. So cotangent would be 3 over 4. Did we get those? So you'll notice some of these things are the same. Sine of A and cosine of B are identical. Cosine of A, sine of B are the same. Tangent of A and cotangent of B are the same. Cotangent A, tangent B. Cosecant of A is secant of B. And secant A is cosecant B. What kind of angles are A and B? They're in a right triangle. And this is 90 degrees. So what do A and B add up to? 90. So A and B are complementary angles. Well, this is a property called cofunctions. So cofunctions are equal when the angles are complementary. So the cofunctions are sine and cosine, tangent and cotangent. Secant and cosecant. So the cofunction just has the word co in front of it. And they're equal if their angles add up to 90. So if I said sine of 10 degrees, that's going to be equal to cosine of what? The sine of 10 would equal the cosine of 80 degrees. If I said the tangent of 50 degrees, that would have to equal cotangent of what? 40 degrees. If I said secant of 12 degrees, that's equal to cosecant of 78 degrees. So I know these things have the same value because of this cofunction property. So our example, I'm going to solve for theta if secant of 5 theta plus 14 degrees is equal to cosecant of 2 theta minus 8. Okay, secant and cosecant are cofunctions, so if they're equal, what's true about their angles? Not equal. When are the cofunctions equal? When the angles are complementary. So I know these two angles will add up to 90 degrees. So if I solve that, 7 theta plus 6 equals 90, so 7 theta equals 84. Divide by 7. So theta would have to be 12 degrees. So if two cofunctions are equal, their angles have to add up to 90 degrees. Any questions? So now we are going to start getting into some of our special angles. What I have here is a 30, 60, 90 triangle and the corresponding sides. And if you're really curious, I didn't just like pick arbitrary numbers. Just a little side note, some geometry here. So I started with, to find these sides, I started with an equilateral triangle with every side of 2. If the sides are all the same, the angles are all the same. So what would these angles all be? 60 degrees. And what I did is I dropped the perpendicular. Okay, so perpendicular would come straight down. So now this side is 2, this angle is 60. That's perpendicular, this is 90. So this angle is 30. So if that was half the angle, this has to be half the side. That whole thing was 2, so this part is 1. And then I did a squared plus 1 squared equals 2 squared. So that's where I came up with this triangle. I didn't just put random measurements on it. That's truly what it comes out to be. So, using that, if I asked you for the 6 trig functions of the 30-degree angle, so sine of 30 degrees. So sine is opposite over hypotenuse, so that would be cosine of 30. Adjacent over hypotenuse would be tangent of 30. Opposite over adjacent will give me 1 over square root of 3, which is radical 3 over 3. Okay, what's the reciprocal of sine? So the cosecant of 30 degrees is 2 over 1 or 2. Reciprocal of cosine is secant. So the secant of 30 degrees is 2 over radical 3 or 2 radical 3 over 3. Reciprocal of tangent is cotangent. So it'll be radical 3 over 1 or radical 3. Okay, and these values don't change if I take a similar triangle. We know that in similar triangles, sides are proportional. So for any 30-degree angle, your ratios will come out to these values. So sine of 30 degrees is always 1/2. Cosine of 30 degrees is always radical 3 over 2. Okay, they always reduce the sum. We're twins. Okay, so this is the first of our major angles that we see. The sine of 30 degrees, cosine of 30 degrees. So 30 degrees is important. We could also do these for 60 degrees, right, from the same triangle. And we'll come back and do that in a little bit. So sine of 60 degrees would be radical 3 over 2, because the sine of 60 is going to be the same as cosine of 30. They're cofunctions. All right, so 30 and 60 are 2 of our main angles. The other one is 45. So let's talk about a 45-degree angle. So if I set up a triangle, okay, we have to have a right triangle. If this angle is 45 degrees, what's this angle? If those angles are the same, what has to be true about the legs? Those are the same. So I'm going to call both of those 1. You could pick any value you wanted, but. All right. So if I find my missing side, 1 squared plus 1 squared equals c squared. So c squared is 2, so this side is the square root of 2. All right, take a second and see if you can write down all 6 trig functions for 45 degrees. What did you get for the sine of 45? Because it's 1 over the square root of 2, so radical 2 over 2. Which means cosecant of 45 is? What's the cosine of 45? Because sine and cosine are cofunctions, and 45 plus 45 is 90. They're the same. So secant is radical 2. What's the tangent of 45? And cotangent then is 1. All right. Did we get those? So these values come up so often, we really need to learn them. We could go back and draw a triangle every time we need to figure out sine of 30 degrees, but that's just very time consuming, and it's something we will use a lot. So I have lots of different tricks for helping you guys memorize this stuff. But if I tell you 6 different tricks in one day, you're just going to be confused. So I'm going to start with this one. This is usually everybody's favorite. If you don't like this one, I have others, so don't just get frustrated and think you can't learn them. I have other tools. but I'm starting with this one. So our hand trick. Our fingers are going to be the common angles that we will see in this class. So that is 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. Okay. The pattern for sine is going to be the square root of the top divided by 2. And I'll explain why in a second. Cosine is the square root of the bottom divided by 2. And tangent, because tangent is sine over cosine, it's square root of the top over square root of the bottom. Okay, so here's how it works. We're going to fill in this table. Okay, now some of these angles we could already fill in from what we've done in class, but we're going to use our hand to do that. When I say 0 degrees, I'm going to fold in my 0 degree finger, which is my thumb. Okay, sine is the square root of the top divided by 2. How many fingers do I have above the one that I folded in? None. So it's the square root of 0 divided by 2, which is just 0. Okay, if I wanted cosine right now. Cosine is the square root of the bottom over 2. How many fingers do I have below the one I folded in? 4. So it's the square root of 4 divided by 2. Square root of 4 is 2. 2 divided by 2 is 1. Okay, tangent. Square root of the top over square root of the bottom. How many fingers above? And below is 4. So I get 0 divided by 2, which is 0. Okay, I'll come back and do the other 3 trig functions in a minute. I just want to talk about sine, cosine, and tangent for a minute. So at 30 degrees, fold in your 30 degree finger. So the sine of 30, square root of the top over 2. How many fingers do we have above the one we're holding down? So square root of 1 is 1, so it's 1/2. And isn't that what we got in our triangle earlier? So cosine, square root of the bottom over 2. So how many fingers do I have below that one? 3. And does the square root of 3 over 2 reduce? No. So I'm just going to leave it. Okay, tangent. Square root of the top over square root of the bottom. So I have 1 above, 3 below. You have to get the radical off the bottom, so that's radical 3 over 3. Okay, did that match what we had for sine, cosine, tangent in our 30-degree triangle? Okay, 45, so fold in your 45 finger. So sine, square root of the top over 2. How many fingers do we have above the one we folded in? 2. And radical 2 over 2 doesn't reduce. Cosine, square root of the bottom over 2. How many fingers below it? So square root of 2 over 2. Tangent, square root of the top over square root of the bottom. So square root of 2 divided by the square root of 2 is 1. All right, 60. So sine, square root of the top over 2. So that would be cosine, square root of the bottom over 2. top over square root of the bottom. So square root of 3 over the square root of 1. This is square root of 3. And 90. So if you fold in your 90, and this is where I struggle because I can't hold my pinky down. I don't know, can you guys? I can't bend my pinky at all. So I'm going to hold it down. So sine, square root of the top over 2. How many do we have above it? So square root of 4 over 2. So 2 divided by 2 is 1. Cosine, how many are below it? So square root of 0 over 2 is 0. Tangent, square root of 4 over square root of 0. Can we divide by 0? So that's undefined. Alright. What questions do you guys have for me there? Do you understand how I got all those? If I have those 3, how would I get the other 3? So cosecant is the reciprocal of sine. So reciprocal of 0 is undefined. Reciprocal of 1/2 would be 2. If I did the reciprocal of 2 over the square root of 2, you just get square root of 2. I do the reciprocal of 2 over the square root of 3. You get 2 radical 3 over 3. The reciprocal of 1 is still 1. Secant is the reciprocal of cosine. So I go through my cosine row. Reciprocal of 1 is 1. Reciprocal of radical 3 over 2 is 2 radical 3 over 3. Reciprocal of radical 2 over 2, we worked it out above, that's radical 2. Reciprocal of 1/2 is 2. Reciprocal of 0, undefined. And cotangent, reciprocal of tangent, so reciprocal of 0, undefined. Reciprocal of radical 3 over 3, this is square root of 3. Reciprocal of 1 is 1. Reciprocal of radical 3. Radical 3 over 3. And reciprocal of undefined is 0. So, these are the trig functions with the main angles we need. These are the only angles that we will need all semester long. So if you learn these, you're good. Okay, if you can do your hand trick and figure them out, that's all you need. So people that believe me and learn these sooner do much better. People that try to fight me and pretend they won't need them, they struggle. Okay, these are the ones we have to know. There are tons of patterns I could talk about here on how we got these numbers. So if you are confused, I will give you other options, but if I just throw them all at you, I think I'll probably overwhelm you more. So this is what I want to start with. We are going to end here for today. We will pick up with this stuff tomorrow and finish up the section. So you may start your homework, but it will not be due until Wednesday. And tomorrow we're going to practice using those values.